The herpes viruses that I mentioned before, those DNA viruses, are some of the most commonly studied pathogens that are just understood to be accumulated and picked up by people over the course of their life. So most people acquire, for example, Epstein-Barr virus. In some cases, they get it, that's mononucleosis, the kissing disease that sometimes people get in college when they get mono. Well, that's Epstein-Barr virus that drives it. And the thing is, once you have gotten mono or Epstein-Barr virus, it now stays in your system. You have that virus for the rest of your life. The thing, though, is that in people who don't develop symptoms, the virus is kept in a state of latency. It's kept in check. So the immune system is monitoring and saying the virus could potentially create more proteins and begin to cause more problems. The immune system says, no, I'm not going to let you. And it keeps it in check in a state of latency. As you mentioned, interferons are signaling molecules that are part of the immune response, part of what's called the innate immune response, which is a basic, important part of just control of most organisms in the human body. And the interferons have a particular viral signaling effect that keeps viruses in check. So if you have robust interferon signaling, which is part of this innate immune response, those interferons are going to be circling and keeping, let's say, a virus like Epstein-Barr virus in that state of latency. But the problem is, if you have another issue that depletes or interferes with interferon signaling, and for example, that could be a new infection. So SARS-CoV-2, for example, creates a number of SARS-CoV-2 proteins downregulate or disable interferon signaling. It's a really potent disruptor of interferon signaling. So let's say you get SARS-CoV-2, now your interferon signaling that was keeping that herpes virus in check goes down or gets dysregulated. That can create an opportunity for that virus that was in a latent state to activate and now potentially infect a new site, infect a new nerve, or create proteins that start to cause problems. And then again, now it becomes more of an active virus. So we have this constant dynamic where we acquire these viral pathogens throughout our lives, and we hope that our immune systems are strong enough to keep them in check. And yet the other infections and other exposures that we get, or simply stressful events, or other things that can impact the immune response, are always shifting the way that we might be able to manage those viral infections that we acquire over time. And the thing to consider is that some of these infections can be acquired in the womb. So it's still an area of study, but it's possible to pass a herpes virus to a fetus in the womb. So for example, if the mother's infected, by the infant as it's growing in the womb may also just acquire that virus. So it's actually possible to even be born already with some of these viral passengers, which means that it's interesting to think about the fact that the diseases that these viruses are capable of causing may run in families in a sense, because we're passing viruses technically, especially down the maternal line. And so sometimes if we see illnesses or chronic conditions run in families, it doesn't only have to be because of the human genome and our human genetics, which also do dictate chronic disease, but it could also be in some instances because of the passing of pathogens that we pass amongst families as well.